Hello everyone, welcome to Educational Data Mining Conference. I'm Sahan Bulatwala, currently affiliated with Center for Artificial Intelligence at the University College London. Today we are presenting our work Predicting Engagement in Video Lectures, which is done as part of the X5GON project. Due to the popularity of massive open online courses, open educational resources, and video platforms such as YouTube, the creation of educational resources in the recent years has rapidly increased. In order to provide a good learner experience using video lectures, engaging educational materials have to be identified and presented to the learners while preserving the other aspects of a high-quality educational material. What this means is that identifying the engageability or the engagement potential of video lectures also attributes to quality assurance of video lectures. When we think about learner engagement, we recognize two types of engagement. There is contextual engagement that associates to the context of the learner. What this means is that the engagement that attributes from the interests of the learner, the learning goals of the learner, and also it could attribute to the emotional state or the affective state of the learner. Also, we recognize context-agnostic engagement, which represents the overall engageability or the engagement potential of an educational material. This does not associate with the context of the learner. Rather, it associates to the attributes of the lecture or the educational material itself. It could be looked as the marginal engagement of a video lecture across a learner population. In this work, we focus on context-agnostic engagement because we see the value of context-agnostic engagement in several promising use cases. In order to build a predictive model that predicts context-agnostic engagement in video lectures, we formulate 6 research questions that will answer this question. Learner engagement associates with better learning outcomes in both online settings and offline classroom settings. And in the recent years, there has been a lot of work that discusses the need of scalable quality assurance of educational materials and also shows the opportunity of building specific quality instruments, which are tools that address specific or subparts of the quality assurance process. When we look at literature outside education, such as domains such as information retrieval, we can see that machine learning models have been used to predict quality or to predict engagement. Some of the examples here is that it has been used to predict the quality of Wikipedia articles. And also there have been work where it tries to predict the engageability of YouTube lectures. When we focus on engagement of video lectures, there are a few noteworthy works that has to be brought forward as well. One of those works is the work from Guo and the group. Here they focus on MOOC videos and use median normalized engagement time as a suitable proxy for learner engagement. The missing part, limitation of this work is that the discussion about the engageability is done in a qualitative sense. Then there are other works that focus on YouTube videos such as Wu et al. However, the problem with these works is that it doesn't focus specifically on educational videos. And when we look at the researchers from YouTube, there have been work that shows why watch time related engagement metrics could be more reliable compared to, for example, popularity based engagement metrics such as clicks because of its robustness to phenomena such as clickbait. In order to build a context agnostic engagement prediction model that can rank video lectures, we devise a methodology that consists of several experiments that answer the 6 research questions that we set out in the beginning of this research. We identify median normalized engagement time to be the best label that can be used as a proxy for learner engagement with. Then we create 3 different variants of engagement representations using the median engagement time based on the literature from subjective assessment and also pairwise comparison literature. Based on the literature that we saw, we also identified features that are easily extractable from video lecture transcriptions. These features are divided into 2 different components: the content-based features that are cross-modal features that can be extracted across different modalities such as PDFs or video lectures, and also video-based features that are very modality specific to videos themselves. These features belong to both continuous and categorical variable types, and we categorize these variables into the quality verticals that we have identified in our previous work. Now that we have identified the labels and the features, we can create and construct the ideal dataset that we can use in order to build a prediction model. To do that, we use the data from videolectures.net, an open educational resource repository that keeps research talks from peer-reviewed conferences. From this data source, we identified 4,063 video lectures that have been published between September 1999 and October 2017. And we used 155,000 user view events. Then, as part of the experiment, we tried to empirically assess the predictability of median engagement from these video lectures using popular machine learning models, and we also use SHAP analysis in order to identify the feature influence. Now, let us look at some notable results. Here, we use pairwise ranking accuracy with 5-fold cross-validation in order to evaluate performance of our models. Where kernelized models are used, we use the radial basis function kernel. From these results, what we can see is the random forest regressor model with the raw representation of normalized median engagement time gives the best predictive performance. In the next section, we take this best performing model and we further investigate this model to answer the remaining research questions. From the subfigure A in this slide, you can see the SHAP analysis that we conducted. Some notable observations here is that the word count is the most influential feature when it comes to predicting engagement with video lectures. What you can see from this plot is that the more the word count is for a particular video lecture, the less engaging it gets. Similarly, you can also see that the more recent a lecture is, which means if it has a later publisher date, that leads to higher engagement, which means more fresh material gets more median engagement. Most of these findings from the feature influence is sensible, and we see them aligning with the findings from the previous work. We can also see from subfigure B how the context-agnostic model is useful in a cold start scenario. To explain this plot briefly, what we have done is we take the most active users we've taken a subset of users from our data set, and then we have used the context-agnostic model and a personalized model to predict the engagement of individual events. And then we have calculated the mean absolute error of these predictions and calculate the difference between the two predictions, where the two predictions are one coming from the context agnostic model and one coming from the contextual model or the personalized model. What you can observe from the subplot B in this figure is that the less number of events there is in the training data, or the less number of events there is for a user, the context agnostic models mean absolute error is less compared to the contextual or the personalized model, which means until you get about 60 to 70 events in this data set from an individual user, the context agnostic model gives better predictions of engagement compared to the personalized model. This demonstrates the usefulness of a context agnostic model that we have created in a cold start scenario where we don't have a lot of user data. Then we also further investigated how the modality-specific features and the domain-specific data would impact the predictions. In the first table on the top, what you can see is the predictive performance of the machine learning model that only uses content-based features, which is the cross-modal features, in comparison to the feature set where there are the cross-modal features plus the video-specific or modality-specific features. Here you can observe that by adding the modality-specific features, we are getting a small increment of the pairwise accuracy performance. But something noteworthy here is that just by using content-based features alone, we have achieved a substantial amount of accuracy in comparison to the increment that you get by adding modality-specific features. In the second table below, what you can see, what we did was we used data from lectures that belong to STEM subjects versus other miscellaneous subjects such as social science, business studies, and we tried to build two different models for these two subject categories and tried to compare that with a subject agnostic model that trains on all the lectures regardless of the domain category that they belong to. From this table, what you can see is that by using all the data without separating out the data as STEM and miscellaneous and training two separate models, contrary to that, if you use all the data and train one context agnostic engagement prediction model, you achieve superior performance. So what conclusions can we derive from this work? One of the main conclusions that we can derive is that predicting engagement involves nonlinear features that are better captured by kernelized models or ensemble models such as random forest model that perform best in this analysis. There's also, we have shown that a substantial amount of performance can be achieved just by using cross-modal features to predict engagement. We saw that the length of a lecture plays a core role in how engageable a video lecture is. In our experiment, we also demonstrated and showed that a context-agnostic prediction model can be used to address the cold start problem when there are no user data available. And we also see that a domain-agnostic model is sufficient for doing engagement prediction. Based on this work, we see several limitations. One of those limitations is the lack of authority or topic coverage related features in this dataset. And then we also see that we've only used very easily automatable features in this dataset. And when you look at this dataset, we also have a majority of English video lectures in this data, which drives us to our future directions. The code and the dataset for these experiments can be found in the link given here. If you need more information about this work, please do not hesitate to contact us. Thank you.